Chapter 2 Web APIs. There's more to Web APIs than just returning JSON payload. In the preceding chapter, we learned about the essential aspects of the web and HTTP, the application layer protocol that drives it. In this chapter, we'll talk about the evolution of Web APIs, cover various Web API-related concepts, and discuss different styles and approaches for designing Web APIs. What is a Web API? A Web API is a programmatic interface to a system that is accessed via standard HTTP methods and headers. A Web API can be accessed by a variety of HTTP clients, including browsers and mobile devices. Web APIs can also benefit from the web infrastructure for concerns like caching and concurrency. What about SOAP web services? SOAP services are not web-friendly. They are not easily consumable from HTTP clients, such as browsers or tools like curl. A SOAP request has to be properly encoded in a SOAP message format. The client has to have access to a web service description LAN. WSDL file, which describes the actions available on the service, and also has to know how to construct the message. This means the semantics of how to interact with the system are tunneled over HTTP rather than being first class. Additionally, SOAP web services generally require all interactions to be via HTTP post. Thus, the responses are also non-clickable. Finally, SOAP services do not allow one to access HTTP headers, which severely limits clients from benefiting from features of HTTP like optimistic concurrency and content negotiation. Origins of Web APIs. In February 2000, Salesforce.com launched a new API that allowed customers to harness Salesforce capabilities directly within their applications. Later that same year in November, eBay launched a new API that allowed developers to build e-commerce applications leveraging eBay's infrastructure. What differentiated these APIs from SOAP APIs? The other emerging trend. These web APIs were targeting third-party consumers and designed in an HTTP-friendly way. The traditional APIs of the time had been mostly designed for system integration and were SOAP-based. These APIs utilized plain old XML as the message exchange format and plain old HTTP as the protocol. This allowed them to be used from a very broad set of clients, including simple web browsers. These were the first of many such web APIs to come. For the next few years after Salesforce and eBay took these first steps, similar APIs started to appear on the scene. In 2002, Amazon officially introduced Amazon Web Services, followed by Flickr launching its Flickr API in 2004. The Web API revolution begins in the summer of 2005. ProgrammableWeb.com launched. Its goal was to be a one-stop shop for everything API-related. It included a directory of public APIs, both SOAP and non-SOAP, containing 32 APIs, which was considerable growth from 2002. Over the next few years, however, that number would explode. APIs would run the gamut from major players such as Facebook, Twitter, Google, LinkedIn, Microsoft, and Amazon to then small startups like YouTube and Foursquare. In November 2008, Programmable Web's directory was tracking 1,000 APIs. 4 years later, at the time of this writing, that number exceeds 7,000. API growth is accelerating, as just about a year ago the number was 4,000. In other words, it is clear that web APIs are here to stay. Paying attention to the web, the earliest web APIs weren't necessarily concerned with the underlying web architecture and its design constraints. This had ramifications such as the infamous Google Web Accelerator incident, which resulted in a loss of customer data and content. In recent years, however, with an exponential rise in third-party API consumers and in devices, this has changed. Organizations are finding they can no longer afford to ignore the web architecture in their API design, because doing so has negatively impacted their ability to scale, to support a growing set of clients, and to evolve their APIs without breaking existing consumers. The remainder of this chapter is a primer on web architecture and HTTP as they relate to building web APIs. It will give you a foundation that will allow you to leverage the power of the web as you begin to develop your own web APIs using AskNet Web API. Guidelines for web APIs. This section lists some guidelines for differentiating web APIs from other forms of APIs. In general, a key differentiator for web APIs is that they are browser-friendly. In addition, web APIs can be accessed from a range of clients including browsers at minimum. Support standard HTTP methods such as those mentioned in Table 1-1. It is not required for an API to use all of the methods, but at minimum it should support GET for retrieval of resources and POST for unsafe operations. Support browser-friendly formats. His means that they support formats that are easy for browsers and any other HTTP client to consume. A browser client can technically consume a SOAP message using its XML stack, but the format requires a large amount of SOAP-specific code to do it. Formats like XHTML, JSON, and form URL encoding are very easy to consume in a browser. Support browser-friendly authentication. His means that a browser client can authenticate with the server without requiring any special plugins or extensions. Domain-specific media types. In the previous chapter, we learned about the concept of media types. In addition to the general-purpose types we discussed, there are also domain-specific media types. Those types carry rich application-specific semantics and are useful in particular for web API development where there are rich system interactions rather than simple document transfer. vCard is a domain-specific media type that provides a standard way to electronically describe contact information. It is supported in many popular address book and email applications like Microsoft Outlook, Gmail, and Apple Mail. In Figure 2-1, you can see the same contact represented as a vCard. Figure 2-1. Contact vCard representation. When an email application sees a vCard, it knows right away that this is contact information and how to process it. If the same application were to get raw JSON, it has no way of knowing what it received until it parses the JSON. His is because the JSON media type does not define a standard way to say I am a contact. The format would have to be communicated out of band through documentation. Assuming that information was communicated, it would be application-specific and not likely supported by other email applications. In the case of the vCard, however, it is a standard that is supported by many applications across different operating systems and form factors. We can mint new media types as applications evolve and new needs emerge by following the IANA registration process. T. His provides a distinct advantage because we can introduce new types and clients to consume them without affecting existing clients. As we saw in the previous chapter, clients express their media type preferences through content negotiation. Media type profiles. It makes a lot of sense for media types that are used by many different clients and servers to be registered with INA. But what if a media type is not ubiquitous and specific to an application? Had it be registered with INA? Some say yes, but others are exploring lighter weight mechanisms, in particular for web APIs. Media type profiles allow servers to leverage existing media types like XML, JSON, etc. and provide additional information that has the application-specific semantics. The profile link relation allows servers to return a profile link in an HTTP response. A link is an element that contains a minimum of 2 pieces of information: a rel or relation that describes the link, and a URI. In the case of a profile, the rel will be profile. It is not necessary for the URI to actually be deferential, meaning you can access the resource, though in many cases it will point to a document. The challenge with using profiles today is that many media types do not currently support a way to express links, so clients would not be expected to recognize the profile even if it were in the content. For example, JSON is a very popular format used by web APIs, but it does not support links. Fortunately, there is a pre-established link header that can be used in any HTTP response to pass a profile. Using the earlier contact example, we can return this header to tell the client this is not just any old JSON, it's JSON for working with Example.com's contact management system. If the client opens their browser to the URI of the link, they can get a document that describes the payload. This document can be in any format, such as the emerging application-level profile semantics helps data format, which is designed specifically for this purpose. http://1.1200 OK content type application/JSON, charset equals @8 link, rel equals profile. Date Friday, the 21st of December, 2012 064725 GMT. Content length 183. Contact ID 1, name Glenn Block, address 1 Microsoft Way, City Redmond, State WA, zip 98052, email blockmicrosoft.com, Twitter block, self. /contacts/1. Multiple representations. A single resource can have multiple representations, each with a different media type. To illustrate, let's look at 2 different representations of the same contact resource. The first, in Figure 2:2, is a JSON representation and contains information about the contact. The second, Figure 2:3, is the avatar for the contact. Both are valid representations of state, but they have different uses. Figure 2:2. Contact JSON representation. Figure 2:3. Contact PNG representation. The JSON representation will be passed and data such as the contact name, email address, etc. will be extracted from the JSON and displayed to the user. The PNG representation, however, will just display as is. Because it is an image, it could also easily be passed as the URL for an HTML tag or consumed directly by an image viewer. As the previous example shows, the advantage of supporting multiple representations is to allow many different clients with different capabilities to interact with your API. API styles. There are many different architectural styles for building web APIs. By style we mean an approach for implementing an API over HTTP. A style is a set of common characteristics and constraints that permeate the design. Each style has trade-offs and benefits associated with it. The important thing to recognize is that the style is an application of HTTP, it is not HTTP. For example, Gothic is a style applied to architecture. You can look at various buildings and determine which are Gothic because they possess certain qualities, such as ogival arches, ribbed vaults, and flying buttresses. In the same way, API styles share a set of qualities that manifest in different APIs. Today we see a number of styles, but they land in a spectrum with RPC on one side and REST on the other. The Richardson Maturity Model. The Richardson Maturity Model RMM by Leonard Richardson introduces a framework for classifying APIs into different levels based on how well they take advantage of web technologies. Level 0, RPC-oriented, a single URI and one HTTP method. Level 1, resource-oriented, many URIs, one HTTP method. Level 2, HTTP verbs, many URIs, each supporting multiple HTTP methods. Level 3, hypermedia resources describe their own capabilities and interactions. The model was designed to classify the existing APIs of the time. It became wildly popular and is used by many folks in the API community for classifying their APIs today. It was not without issue, though. The model was not created to establish a rating scale to evaluate how RESTful an API is. Unfortunately, many took it for just that and began to use it as a stick to beat others for not being RESTful enough. This appears to be one of the reasons why Leonard Richardson himself has stopped promoting it. Throughout this chapter, you'll dive more deeply into the different levels of RMM and see real-world examples. We'll use the levels to discuss the benefits and trade-offs associated with how you design your API.